Hello, it's Duncan. What you see with these videos is normally a second or third take. If I try something and it turns out to be blatantly silly, I don't inflict that on you, but mostly I try to show sessions as they happened, just a bit smoother because I practiced. I then edit out the fat-fingered keystrokes and audio stumbles in order to get the thing finished before you lose interest. I try to balance pace and honesty. My assumption is that you don't want to sit through the tedium of real-time programming, at least not my real-time, but you don't want to miss anything significant either. This may give the impression that I'm a better touch typist or refactor than I am, but I haven't planned the whole app. I have to live with the design decisions that I made in previous installments. This episode, though, is a bit different, because I wrote only one line of production code and then tried to break it, which is pretty tedious. So this one is far more, here's one I prepared earlier. We left last time with this stock tests and a stock class. And the stock class needed to know how many days there were between 2 days, 2 instants in fact. So an instant is a universal time, doesn't matter where in the world you are, and we need to know how many days had passed since the stock file had been updated in order to know whether we needed to update it now. And we blatantly cheated. We hard-coded the result of instant day between to give the result that the stock test required, because we could see this was going to take some thought, and I didn't really want to flick that thought on you. So here we are. I've done the thought, and let's cut straight to the chase. Here is what I think should work. So in order to establish effectively how many midnights there are between 2 instants, you need to know which time zone you're asking in. Because if I'm in GMT and I ask the question, how many seconds are there between 1 second to midnight UTC and 1 second past midnight UTC, the answer is 1. Whereas if I ask the same question and I'm in California, it would be very different. There'll be no days difference. So we need to know the zone, and I think what should work is that we take a local date of our instant in zone, and we take both of those, and we ask each for their epoch day. And the epoch day is the number of days since the beginning of the epoch, which I think is 1170. And so this will give us the offset in that time zone from one time to another in days. And I believe that should work. And the rest of this really is trying to prove that I'm right. Or in fact, more sensibly, I suppose, it's trying to prove that I'm wrong. Because I kind of believe I'm right, but if I am wrong, then that's pretty disastrous. So we're going to try and break this. We're not going to try and prove I'm right, we're going to try and prove I'm wrong. Okay, so let's look at the first test that I wrote. I picked a single time zone, and this feels a little cheating, but it's a time zone I have an intuitive feel for when things change. We might want to look at other time zones later. So first of all, we're going to check that there are 0 days between 2 times that are the same. So if we try this time here, which is 1st of January, midnight 1st of January, there should be 0 days between those two, 0 midnights between those 2 times. Similarly, if we look between the beginning of a day and the very end of that day, there should be 0 days. And just to be clear, this time here is parsing an offset date time and making an instance out of it. This is an offset date time. Z is Zulu, which is 0 offset hours from GMT, or from UTC. And done the same way, well, done the other way around, going from the very end of the day, days to the beginning of the day should be 0. But if we start at the end of one day, which is the first, and go to the end of the second day, another day, which is the second, the very beginning, that should be 1 day. We've crossed midnight once. And the opposite should be true. So if we reverse these, we should get -1. So that was a test I wrote at the very beginning in order to just have some confidence something was working. Now the devil is in time zones. So we're now going to look at what happens in June. In our London time zone, in June, our time is an hour ahead. So we basically have the same test, but we should have different results. So the time between two times are the same, that should be still 0. But if we look at the beginning and end of the same day in UTC, when we look at that in GMT, actually there's a day between them because the time zones are shifted. And that is reversed if we look at them the other way around. And it's also the case then that the previous two times that were shifted by a day, different by a day, are now not different by a day. So we're gaining a bit of confidence. Now we'll say, let's repeat the first test. This time we'll repeat that test in June, but instead of taking times in as if they were UTC, we'll take times as if they were GMT, as if they're 1 hour ahead. And the results then should be the same as they were in January, at least for those times. So where we shifted the 1st of January to the 1st of June. And that's what we see. So again, a little more confidence. And if we parse the times in local time, well, the local time should be the same as this offset of 1. And so this should give the same results for January as well. And local here is saying if we take a local date time and parse it and look at that as an instance in London. So these instants in this case should be the same in these tests as they were in these tests, because in London this was +1 on will be +1 on 6th of June. This is really, I don't know whether it's gaining confidence in my understanding of the Java time libraries or in the performance of that code, probably a bit of both at the same time. Now we're going to look at places where daylight savings are actually changing underneath our clocks. So daylight savings time changes on the 29th of October. And so we check around that time to see that we do see a change. And the same, it changes in March, so we'll check that way around as well. I won't bore you with the details, but I believe this is showing sensible behavior. I'm still not entirely convinced though, and I want to go at this a different way. So this next test builds local date times where we know the difference, what we expect the difference to be in days. So it starts at day 0, which is the local date of 1st of the 1st, 2000, say. And it says, oh, let's offset by up to 5,000 days. And that will give us, we can have a local date that is that first day plus up to 1,000 days, up to 5,000 days. Then we'll pick a date time that's the beginning of that, just at the very end of the first day. And then we will add some days onto that and some minutes onto that. And finally, we build a date time, another date time. So we've got 2 date times, one of which is at 23:59:59, and another one which is at a whole set of minutes after that in the next day. We'll make those instants in some zone. And then we know how many days we added here from 0 to 366 from our local date, which we continually shifted on. And so we know what we expect our result to be here. So this sort of turned the problem on its head. We said we can start from local dates and times and push those back into instants where we know what the answer should be, and we'll check the answer, and we'll check them both ways around. The problem with this is that this test takes ages to run. And you may be able to hear the fans still whirring on my MacBook. In fact, 1 minute and 46 seconds. And the problem here is really that we're testing lots and lots of times that aren't interesting. And so I've disabled this test for our main run, and I think probably we can get rid of it. But the knowledge that we're testing things that aren't interesting to us gives us another clue of what we can do. So my plan finally is to say, let's pick some zone IDs and some interesting months. And the months I picked as interesting are January, March, October, and December. January and December because they are at the end of the year, either end of the year, and these 2 months because they are when daylight saving tends to change. And so now I'm going to pick some years, and I'm going to pick the years between 1970 and 2040 as the beginning of time as far as computer programmers are concerned. And 2040 we should, well, I'll be retired and everything will be good. And I'm going to build a sequence of local dates of year, month, and days. And the days I'm going to pick every month, every day in that month. So we're going to end up with every day in every month for 4 months in each of 70 years. And then we're going to pick some specific times. So we're going to pick some times before midnight, and they are the beginning of the day, 1 second after the beginning of the day. We're going to pick midday, we're going to pick an hour before midnight, and we're going to pick just before midnight. And then times after midnight, these are a bit more specialist. We're going to say we're going to pick the very second of midnight, we're going to pick 1 second after, and we're going to pick 1 and 2 hours after. And the reason for 1 and 2 hours is that's because daylight savings, when daylight savings changes, tend to kick in. And then we're going to build a list of days that we want to add to whatever start day we have. So these are the offsets that we expect to see, and they are 365 days, plus and minus 365 days, 366 days, just in case, and then -1 and -2 and 1 and 2 days. Okay, so finally we're going to build combinations. So we're going to take each zone ID and each local date to give us a start date. And to that start date we're going to add plus days. And the end date is going to be the start date plus the number of days. And then for each of the times before midnight, we're going to add that to the start time. And for each time after midnight, we're going to add that to the end time, which is going to give us an end date time and a start date time. So we've got start date time and an end date time. And those two things we're going to convert to an instant in the zone ID. And then we knew how many days that we'd added. So we can go one way around, and we think that we should get the negative result to go the other way around. So this should be testing lots of the points that the other one was, but also we could add in zone IDs as well. And because we're only looking in interesting places, this test is very much quicker. Is this good enough? I don't know. I've reviewed it with a friend. I believe so. But if anyone out there can show some places where our current code, which is instant days 2, doesn't work, then that would be fantastic. Because we'll save Gilded Rose potentially money trying to work out what went wrong and fix up our data. I guess we have the final question of, does it actually work? So let's find out. Let's take this here and cut it from there where it is and go back to our stock tests. Our stock testers call this days between, and we've called it days 2 here. I think days 2 is better because days between might imply number of whole days, whereas days 2 makes you think about it. I don't know. I think probably I would make this private fun in here. Well, in fact, I'm going to have to make it internal to be seen by the tests, just to limit the damage if we are wrong. Now, in order to call that instant days 2, we're going to need a time zone. And so our stock should know about a time zone. So we can pass that in here, zone ID there. And so where we build this, we were working in London, so we'll go with zone ID of Europe. Try and run this test and just check that at the very least it works. Okay, well, that's a little tidy up. IntelliJ tells us we could make both of these private, and we may as well. And I think we may be done for the day. Just go back and look at our test just before we do. What do we want to keep? Well, that's a good question. I think that we are probably not worth running this test. I wanted to know that it worked, but now it's been superseded by this one, which may be quick enough. These other ones, they're very quick to run, and I think they explain some of our thinking. So for now, at least, I'm inclined to keep them in. Later on, as we gain confidence in this code, I might get rid of them. I don't know. Oh, let's run all tests. Test still takes a chunk of time. We might want to improve it as if our test runs get too long, but that will do for now. So this is going to be implement instant dot days 2. And remember, this is still only in the test tree, so we haven't committed anything to production at the moment, so we're reasonably safe committing this even if we were to mess it up. Phew. Well, I've got a bit of a sore throat, so I think that's me for today. If you've enjoyed this, then please check out the book that I wrote with Nat Price, Java to Kotlin, a refactoring guidebook. And if you want to see where this takes us with our stock, then please subscribe to the channel and you will hear when I publish that. Thank you very much.